Hi, we're here with Joshua Woolley from Berlin Heart. And Berlin Heart makes a device that helps heart transplant patients, but special ones, actually kids. Joshua, tell us a little bit about the instrumentation we have behind us and give us a little bit of a demo.
So this is a ventricular assist device that provides a bridge to transplant. So if you have a pediatric patient that is in heart failure, this will provide mechanical support for either the failing left ventricle or the right ventricle until they can find a heart transplant for this patient. And we're the only FDA-approved pediatric ventricular assist device.
Some of your patients are babies, in fact, where their heart is literally the size of your thumb. How do you interface with that, something that small?
So our platform works because the pump itself sits outside the body, and then the cannulas or the tubing that hook up to the pump that connect to your heart structures are the only part that sits across the skin. They actually connect to your heart and then cross the skin and connect to the pump that is hanging outside your body. This is very important when you're talking about kids, babies that are like 5 pounds, maybe even less for preemies. And we can support patients 3 kilos all the way up to 60 kilos. So little babies all the way up to teenagers.
And you actually designed your own pumps because pumps for blood have to be specially made so they don't degrade it. Can you tell us a little bit about that?
So our pumps are made of polyurethane, and they have a Carmita heparin coating to try to prevent clotting on the inside of the pump. They also are built to last a long time, obviously. We can't have these things fail, that'd be catastrophic. So our patients generally stay on the VAD for about 1.5 to 2 months before they find a transplant, but the longest patient in the U.S. that we've supported was 1.5 years, and she was successfully transplanted about 1.5 years ago.
You also use National Instruments equipment to actually test the system and make sure it's functioning properly. Can you tell us a little bit about that aspect of operation?
So it's a pneumatic system, and so it's very important that our compressors in our drivers work, otherwise the pump obviously wouldn't work as well. So after we service each driver, our service technicians will hook it up to a National Instruments DAC machine that will measure the characteristic pressure output of each compressor. And we overlay that many times. We run it at 150 beats per minute for almost an hour, and we overlay each pressure characteristic waveform, and it creates a density plot, and the width of that plot has to be within a certain variance to make sure that that compressor works appropriately, so that when they turn it on for that patient, it works every time, all the time.
You have a demo set up here behind us. Could you take us through that?
Yeah, so the part that you're seeing moving here, that is really just to show you that we can pump fluid. So this is biventricular, this would be the LVAD, this is the RVAD, and you can see there's a common reservoir that's feeding both of them, and all it does is just pump to each one. And you can see it moving here, you can see it's almost like a piston effect where you have a blood chamber, an air chamber, and a membrane in between. And by creating a pressure or a vacuum, you move that membrane back and forth, and that pushes the blood out. We have custom-made tri-leaflet polyurethane valves, and those provide the one-way direction, and that's how it achieves the forward flow. Similarly, we have this mannequin over here, and this shows us gives you a cutaway and shows you how the pumps actually interact with the patient and fit within the strictures of the heart.
That's interesting. What was the toughest part about designing a system?
Scaling it down. It actually started as an adult pump, and usually, as you know, it's much easier to scale up than it is to scale down. And we had a lot of trouble. Initially, we had mechanical valves in the adult pump, and it worked really well. It was a much larger pump than what you're seeing over here. And so when you're talking about trying to go to something like this, which is a stroke volume of 10 milliliters, the valves on that have to work appropriately, and the mechanical valves were clotting and having big issues. So we had to go back and redesign the valves to make them tri-leaflet, and that really helped cut back on clotting and help the performance of the device.
Well, that's great technology there, Joshua. That's really interesting. Thank you.
It's extremely rewarding job, and everyone at the company loves it.
Thanks.
Thank you.